Insulin was particularly suitable because it had a lot of small chains, really. And the project he gave me was to try and identify the ends of the chains by chemically labeling. You could label them with a colored substance, in fact. And so I introduced this method really with what's called the DNP method, which was a quick and easy way of identifying the ends of the chains. And the things that made that possible at that time were chiefly a new method of separating things, fractionating, chromatographic. It was called partition chromatography. And you could make these yellow compounds and fractionate them and identify them. And that was the first thing I did. I mean, I didn't have any sort of grand ideas like sitting down and saying I'm going to sequence a whole protein or anything like that. I mean, that makes a good story, and because that's what I did in the end. But the first step was just to identify these two groups at the ends of the chains. And that was the first thing I did. And there was a problem, really. These were yellow substances which you could separate nicely. And we got two, which were glycine and phenylalanine, so we'd identified the N groups. But we had one problem, that the glycine one was rather labile. It was broken down if you hydrolyzed too long. And
Are we okay?
It would break down. So we had to hydrolyze it for a very short time. And when we did this, we found there was another yellow substance turned up. And this yellow substance turned out to be the dipeptide, that is two amino acids joined together. And so I identified this, and it showed me that the N group was phenylalanine valine. And that was the first peptide, the first sequence that was ever determined in a protein.